Fieldwork number 6. Trigonometric Leveling by Catherine Faraon and Mharlheslee Cortina.
Trigonometric leveling involves measuring a vertical angle from a known distance with a theodolite and computing the elevation of the point. With this method, vertical measurements can be made at the same time horizontal angles are measured for triangulation.
Objectives: to acquire and develop the skills of determining the vertical distance of a remote point by applying trigonometric and related analysis. Next is to develop the skills of reading vertical angles using theodolite per station.
These are the instruments and accessories: theodolite, leveling rod, markers, it can be chalk or marking pins, measuring tape, plumb bump, and range pole.
Procedure: Step 1. Set up the theodolite at a convenient location and call it point A where the leveling rod and the remote point are visible. Step 2. Using the telescope, take sight at the topmost remote point, then read the vertical angle and record as alpha on Table 5 Trigonometric Leveling. Step 3. Take another sight for the second trial. This is done to determine the precision of the observations. Step 4. Calculate the mean of the two vertical angles or the angle of the elevation of the specified point from the first station. Step 5. Set the leveling staff or rod vertically near the base of the remote point and take the level foresight on the rod to determine the height of the instrument. Step 6. Transfer the instrument level towards the location of the remote point and designate it as Station B. Then measure its distance by taping from its initial position. Record this as distance AB. Step 7. After centering the bubble of the instrument level, sight at the same topmost remote point twice using the telescope and record as beta on Table 5 Trigonometric Leveling. After recording these two observations of vertical angle, calculate the mean. Step 8. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. Step 9. Analyze the right triangles formed to determine the height of the remote point. This fieldwork will not consider the effects of combined correction of Earth's curvative and refraction.
Analysis of the figure. Number 1. Determine the difference in elevation between two instrument setups. Difference in HI is equals to H sub 1 minus H sub 2. 2. Consider the triangle B prime EF, then solve for distance x using the tangent function. For tangent function, tan beta is equals to H sub 1 minus H sub 2 all over x. 3. Determine the sum of distance AB and distance x for the analysis of the oblique triangle A', F, and B. A', F is equals to AB plus x. 4. Consider the triangle A', FD and use side law to determine the distance FD. AB plus x all over sine divided by beta minus alpha is equals to FD all over sine alpha. For the final step, 5. Consider triangle FDG and determine the height of the remote point DG. Sine beta is equals to h minus h sub 1 all over FD.